The exponential distribution. So the exponential distribution is often concerned with the amount of time until a specific event occurs. So for example, it might talk about the amount of time starting now until an earthquake occurs. And this is what an exponential distribution looks like, if you recall. It is a curve and it gets closer and closer to 0. So let's take a look at some more information on the exponential distribution. So the probability density function is, and here's the notation, x is exponential, and this m represents the decay rate in this scenario. So f of x equals m times e raised to the opposite of m times x, where m, the decay rate, is 1 divided by mu, mu being the mean. So mu is always positive and x always is positive. And in this scenario, in the exponential distribution, the standard deviation equals the mean. So the number e, it's actually in our calculators, and I will show you where it is in a little bit, but e to the x is what we will use to do our calculations. And it's this long number here. You don't have to have it memorized because our calculators already have it programmed in. The cumulative distribution function, this here, down here, gives us the area to the left. So to the left of some value. And when we look at an example, this will make more sense. All right. Let x equal the amount of time in minutes a postal clerk spends with his or her customer. The time is known to have an exponential distribution with the average amount of time to 4 minutes. So we know that the average, the mean, will be our mu value, which we need down here to figure out m. M is the decay rate. So we are trying to find f of x equals m times e raised to the negative m times x. So we know that the m is going to be 1/4 or 0.25, and we know that x is greater than or equal to 0. Here is how we rewrite the distribution notation. So x is an exponential distribution of 1/4. So the standard deviation, remember, is the same as the mean, which equals 4 in this case. So if we say, for example, we want to find f of 5, then we plug it into this equation up here. We do our calculations, and we get 0.072. Now say that we want to find the probability that x is less than 5. So all we have to do is use this, plug it in with our numbers, and get our calculation. Remember that we are not ever going to do equals, that we are looking for a distribution, and it's cumulative. So now we want to find the probability that x is between 4 and 5. So just recall that we've got our exponential distribution here. This up here is our decay rate, which is 1/4, and then 4 is our mean, so it's the average. It's not the same as the median, but it's the average there. And then 5 is somewhere, so we'll just put 5 here. So we are trying to find this area in here. So remember that the cumulative distribution function gives the area to the left. So it gives the whole area. So in order to find this, we have to find the area of x is less than 5, then the area of less than 4, and subtract the 2, and that's how we're going to find out the difference or the area between 4 and 5. So you can see over here we've set it up, and all you have to do is plug in the values here. So 1 minus e raised to the negative m times x, plug it in, and the probability of x is less than 5 is 0.7135. The probability that x is less than 4 is 0.6321. And let me show you how to do this on the calculator. Okay, so here we have our calculator, and make sure it's turned on. We are simply going to do 1 minus, and if you look over here, this LN button, if you look in yellow gold, it says e to the x. So you're going to hit the second button and then this LN, and you can see what it does up here. We are going to put negative 0.25 times 5, close our parentheses and hit enter. And then you do that, and we're going to do the same other times 4, okay? And then we're just going to subtract the 2. So 0.7135 minus 0.6321. So the probability that the value of x is going to be between 4 and 5 is this, which is 0.0814 or 8.14%.